Hello and greetings, first of all, to my beloved lecturer, Dr. Selvi, and to everyone watching. As of today, we are from Group 5. We'll be presenting to all of you our project entitled Fully Integrated Biochemical Sensors for Glucose Detection. First and foremost, let me introduce myself. My name is Muhammad Fahmi Muhammad Zainal. You can call me Fahmi, and here is my other group members. Me, myself, I'll present on the introduction of the design. Then, Fakhruddin will present on the principle and function of the design. After that, Najman will present on explanation and elaboration on the advantages and disadvantages of the design. And for other relevant content, I'll read on the application in industry or daily life. And last but not least, Fakhrul will be presenting on the achievement and challenges using biochemical sensors as a glucose tech. Alright, now let's go to our main course. In this introduction part, a brief idea about it is I will clarify you on the idea on cause of making this project a success and to define part by part of the design of our glucose sensor. We are all aware that monitoring patients' health status is critical for illness prevention and treatment optimization. Diabetes is one of the most common diseases affecting over 450 million people worldwide. It is characterized by persistently high blood sugar levels that cause vascular damage and impair the kidneys, heart, eyes, and nerves. The number of affected people is expected to reach 700 million by 2045, with half of the all diabetic patients remaining undiagnosed. Self-care management interventions, on the other hand, improve patients' glucose control as well as their overall well-being. Specifically, many methods for determining blood sugar levels are now available on the market. Certain circuits allow for alternative site testing, which involves drawing blood from locations other than the finger. Some models may not require coding, whereas others have built-in software that allows users to transfer meter readings to a computer. Then proceed to the design explanation. Figure 2 depicts this. The glucose sensor was constructed using flexible polyethylene terephthalate substrates, which is the standard method for ultra-low current electrochemical sensors. The entire circuit is built around the TinyDuino with an analog circuit providing signal processing, conditioning, and e-ink panel control. The signal conditioning loop uses TLE2426 virtual ground to generate a reference voltage level for differential pulse voltammetry. The LTC6079 amp was combined with a resistor to form a transimpedance amp capable of converting the sensor's current to a voltage signal, which was then fed into an Atmega 328P microcontroller's analog to digital converter. The pre-programmed infinite impulse response filter will denoise the signal. The filter signal is then used as a reference for the display. When a bootloader has been burned into e-ink component, it is interfaced with the TinyDuino microcontroller via the serial peripheral interface and programmed via the universal serial bus as shown in figure 3, which is the circuit diagram. So the glucose detectors enzymatic sensor enables a reduction oxidation reaction with a glucose in sweat and generates output amperometry. The impulse is then amplified and converted to digital signals by TinyDuino's analog to digital converter port. Following that, the TinyDuino processes the digital signals by filtering out high frequency interference and feeding the analyzed data to an e-ink panel for real-time observation. The display provides the advantages of a stable display with no continuous power supply, a wide viewing angle, excellent visibility, and extremely low power consumption. Solar energy converted from photovoltaic cells that can power the system.
My name is Muhammad Fakhruddin and I'm here to explain about the working principle for the biochemical sensor for glucose detection, which is a glucose meter. Okay, firstly, the glucose meter measures the glucose concentration in a solution. The solution that we mention here is of course the blood in our body. Okay, electrochemical test strips are used to perform the measurement in the glucose meter, and a little drop of the solution to be tested is deposited on a disposable test strip, which is then used by the glucose meter to measure the glucose. Okay, so the first step is we need to use our blood from our body as a glucose detection. Okay, the blood sample will then put on the electrochemical strip. Of course, the strip have glucose oxidase enzyme which will react with glucose in the blood and then create a gluconic acid. Okay, the gluconic acid then react with the ferricyanide, which is another component in the testing strip, and ferrocyanide is formed with ferricyanide and gluconic acid when it mix. Okay, the device then passes an electrical current across the blood sample on the strip when ferrocyanide has been produced. And that's how the working principle for the glucose meter. So, there are two common methods used in measurement of glucose, which is colorimetric method and amperometry method. Okay, so for the colorimetric method, the analog interface in this technology is formed using common sense such as LEDs or light sensors. A transimpedance amplifier, or what we call a TIA, is used to monitor the glucose concentration in the solution after the sensors. This approach employs the color reflection principle to detect the color intensity in the response layer of the test strip via photometry. A numerical value is generated by the glucose meter, which is a measurement of the glucose concentration in the solution. For the amperometry method, the electrochemical test strip comprises a capillary that draws in the solution supplies at one end of the test strip in this approach. Okay, so an enzyme electrode carrying a reagent such as glucose oxidase is also included in the test strip. In the presence of enzyme, glucose undergoes a chemical process that results in a production of electron. So, the number of electron measured is related to the amount of glucose in our blood in the solution. So, in order to adjust for the effect of temperature on the pace of the reaction, an ambient temperature measurement is also taken. And the blood sample is placed when the blood sample is placed on the strip and the glucose is reacted with the enzyme. Okay, the current flowing through the working and reference electrode will correlate to the flow of electrons. And depending on the glucose level, this current will alter. A transimpedance amplifier, or what we said before, a TIA, and an analog to digital converter are used to measure the current. And with fluctuating glucose concentrations in the solution, the transimpedance amplifier's output will be observed as a variation in voltage. And so, that's all from me. Thank you.
My name is Amir Najman Arif. So for my part, we're going to see the advantages and disadvantages of this design. So first part, we're going to see the advantages of this design. First of all, this sensor is actually based on low-cost polyethylene terephthalate, which is very effective for measuring concentration changes in fluidic solution. Next, the advantages is we're using PET as a substrate. We know that PET is such a flexible substrate which is very useful in order to fit a various applications such as face patch, contact lens, even in smart band. Next, this design actually gives a potential to generate a new source of non-invasive psychological information by using variety of body fluid such as sweat. Actually, we can get the data, which is the concentration of glucose in our sweat. Last but not least, this design actually gives improvement in clinical feature and analytical identification in chronic illness, along with continuous real-time health monitoring. We're going to see the disadvantages of the design. First of all, this design will be lack in information interpretation since the signal must go through some process before it can be integrated. Next, the disadvantages is it cannot afford a large amount of microchip on top of it, or else it will disturb the flexibility of PET substrate. The disadvantages is sensor need to calibrate the response from time to time due to small changes in the activity of the sensor itself. And last but not least, we're concerned about privacy and security, utilization of new developing sensor technology, the mixing of mobile data and clinical data, and the establishment of validated clinical trials are all being considered in this.
Hello, my name is Arif Zahruddin bin Mohammed, 17104-804, here to talk about other relevant content regarding the design we chose. One factor that is important to the design is the application, whether in daily life or even in industry. Each year, we can see that new inventions in healthcare, fundamental biological research, food safety, and environmental monitoring are proposed and implemented. One study showed that a flexible amperometric sensor embedded in a contact lens was proposed for detecting glucose in tears for everyday use using PET substrates glucose sensors. This glucose sensor was created by depositing titanium, palladium, platinum metal electrodes on a PET sheet and molding it into a shape of contact lens. Following that, a titanium sol-gel film was applied to the surface to immobilize glucose oxidase, and a Nephrion film was used to eliminate interfering chemicals such as ascorbic acid, lactate, and urea. Another study uses iridium trioxide solution to deposit an ultra-thin polymer sheets to construct a printable ultra-thin conformal biosensor. The ultra-thin polymer layer allowed for extremely conformal interaction with curved surface, but the high-density indium trioxide allowed for chemical modification with target-specific functional groups. The sensor may be used in everyday life as well as at the industrial level. According to one study, a thin film PET-based gold electrode or PGE glucose sensor was developed utilizing an ultraviolet mediated chemical plating approach. The PGE glucose sensor is simple, low cost, and requires minimum equipment as compared to other contemporary wearable thin film gold electrode sensors. This may be used in industry, where a corporation can monitor the glucose levels of its personnel in order to increase labor productivity by indicating better healthcare plans based on the data acquired from the sensors.
Hi guys, so my name is Fakul, and for my part it's about achievement and challenges that we can detect from the biochemical sensor as a glucose detector.
Goal, challenges, biochemical sensor as glucose detector. The achievement is detect environmental events and changes and read data to process. And to meet social needs, key sensor performance parameters such as sensitivity, selectivity, stability, and ease of use need to be improved. As the result, research focus on improving the design of sensing mechanism and inventing new active sensing materials. So, what is the conclusion of my part? So as we know, we can detect glucose using various things such as light penetrating, which is LED, colorimetric method, and amperometric method. In recent years, sensory devices and tools have been invented, developed that are intelligent, safe, biocompatible, and environmentally friendly. Wearable electronics such as smartphones, smartwatch, and other mainstream gadgets are included in these touch devices and tools that have various built-in functions. With this technology platform, different parameters of phenomenon can be monitored simultaneously, and new technologies and sensor type have been introduced. So one of the can be monitored simultaneously is CGM, which is continuous glucose monitoring. Okay, that's all from me.